Good morning student. Today we will study Unit 1 Lecture 7 Organic Chemistry. Benzene mechanism. Substitution of halogen KNH2 potassium amide oblique ammonia. Reaction of bromobenzene with potassium amide. Bromobenzene reacts with KNH2 dissolved in liquid ammonia at very low temperature minus 35 degrees centigrade to give aniline. Reaction. Bromobenzene when reacts with bromo. On benzene ring, bromine is attached. So that is bromobenzene when reacts with potassium amide in liquid ammonia at minus 35 degrees centigrade, you are getting aniline and KBr. Benzene mechanism. The mechanism can be explained by formation of benzene intermediate. This intermediate is represented as, this is represented in this way, benzene. On benzene ring, here we are having triple bond, or we can represent it in this way. Benzene is highly reactive short-lived compound having hexagonal ring having 2 double bond and 1 triple bond. So here it is having 2 double bond and 1 triple bond. Its molecular formula is C6H4. The third additional bond is a weak bond, therefore benzene is unstable and highly reactive. The bond which is there, additional bond is there which is weak, and therefore it is a very highly reactive. Benzene mechanism. Benzene is formed when bromobenzene is treated with KNH2 potassium amide. So bromobenzene is reacting with NH2 nucleophile and you are getting benzene. See how the bond is shifting, the H is breaking here and the bond is shifting here and bromine is removed as Br minus. So here and a benzene is formed and triple bond is formed. So this is benzene is formed. Step 2. Unstable benzene again reacts with nucleophile NH2 minus. The carbanion is formed. When it reacts with ammonia, aniline is obtained. This mechanism is a elimination addition. So here what is happening? NH2 is again reacting with benzene. It is attacking on benzene here, and NH2 group is attached here, and again plus ammonia. Again this bond is shifted here, and here you are getting aniline. On benzene ring aniline is there, then is NH2, that is aniline, and NH2 minus is removed. So here from ammonia NH2 minus is removed, again nucleophile is removed. So in this way, this is the mechanism for benzene formation. Next, relative strength of C bond X bond in alkyl, allyl and vinyl halide. First of all, we will see what is alkyl halide. Alkyl halide general formula is R bond X. Example, CH3 CH2 CH2 Cl. Propyl chloride. Then allyl halide is CH2 double bond CH bond CH2X. So this is allyl halide generally, and again here the specific example CH2 double bond CH single bond CH2 Cl. This is allyl chloride. So this much is known as allyl group, and this is halide. So allyl halide, we are attaching chlorine, then allyl chloride. If bromine is attached, allyl bromide. If iodine is attached, allyl iodide. Next, vinyl halide, CH2 double bond CH bond X. So X is general. So this much group is known, up to a CH it is known as vinyl group, and this is X is halide. The example is CH2 double bond CH single bond CH. This is vinyl group to the vinyl group. This much is vinyl group. Chlorine is attached, so vinyl chloride. If bromine is attached, vinyl bromide, vinyl iodide. When chlorine departs from, so one by one we will see. Alkyl halide, its strength we will discuss. The first alkyl halide, then allyl halide, then vinyl halide. First of all, we will take alkyl halide. When chlorine departs from propyl chloride, propyl carbonium ion is obtained which has no resonating structure. Here we are saying propyl chloride is there, and here we are saying propyl carbonium ion is formed and Cl minus is removed, and it is not having any resonance structures. When chlorine departs from allyl chloride, allyl carbonium ion is obtained which has a possible resonating structure. Due to this, allyl carbonium ion is more stable than propyl carbonium ion. In propyl carbonium ion, we are seeing there is no resonating structures, but in allyl chloride, so this is allyl chloride, here carbonium is formed and it is having resonance structures. So when the resonance structures are there, then the molecule is said to be more stable. So it is more stable than propyl carbonium ion, because in when allyl carbonium ion is formed, we are having resonance structure, so it is more stable than propyl carbonium ion. Then in vinyl chloride, pi bond present and p orbital of chlorine interacts and delocalization of pi cloud is possible. So here you are seeing this is vinyl chloride, CH2 double bond CH, single bond Cl. So here pi cloud is there, so pi bond is there, so this is pi cloud is there, and this for chlorine p orbital here. So what happens, p orbital of chlorine makes delocalization with pi bond in vinyl chloride. So this p orbital makes delocalization with pi bond in vinyl group. Hence bond present in between C and Cl get partial double bond characters, and so this bond will get partial double bond character. As a result, removal of chlorine atom will become difficult. So because it is getting double bond character, it is difficult to remove chlorine. Hence vinyl chloride is less reactive than propyl and allyl chloride. Thus alkyl chloride is most reactive and vinyl chloride is least reactive. So alkyl chloride, so thus we can say that alkyl chloride is most reactive, then allyl chloride, then vinyl chloride. That means alkyl chloride is most reactive and vinyl chloride is least reactive. Then this relative strength of C bond Cl in benzyl halide and aryl halide. So how will you write benzyl? So on the benzene ring CH2 is there, then it is known as benzyl group, and chlorine is attached, so benzyl chloride. In chlorobenzene to the benzene directly chlorine is attached, so it is chlorobenzene. Example of aryl halide. So benzyl chloride is more reactive than alkyl and aryl chloride. So benzyl chloride is there, it is more reactive than alkyl and aryl chloride. In benzyl chloride, bond between CH2Cl is not in conjugation as in case of ArCl. Here we are seeing the bond between CH2Cl, this is the bond, which is not in conjugation as in case of in ArCl. That means in this bond here, this is in conjugation with this benzene ring, but here it is not in conjugation. So in benzyl chloride we are seeing that benzyl chloride bond between this is not in conjugation as in case of ArCl. When benzyl chloride, chlorine is departed from benzyl, this is benzyl chloride. When chlorine is coming outside, benzyl carbonamine is obtained, which is stable due to resonance. So here benzyl carbonamine is formed, which is having resonance structure. So resonance in benzyl carbonamine favors release of chlorine from benzyl chloride. Hence benzyl chloride is very reactive. Due to this resonance structure, it is having positive charge, you are seeing. So what is happening, due to resonance structure, chlorine can be removed very easily, and so it is very reactive. In chlorobenzene, bond between carbon of benzene and chlorine, a single bond is present. Here we are having a single bond is there. Benzene is in conjugation system having 3 double bonds and 3 single bonds present alternatively, and chlorine has a pair of electrons. Hence delocalization of pi cloud of benzene extended up to chlorine. So here this is, so here what is happening, it is triple bond is there, and so this is in conjugated system. Benzene is in conjugation system with 3 double bonds. This chlorine is in conjugation with this benzene ring, and so delocalization of pi cloud of benzene extended up to chlorine. So this delocalization of these pi electrons are extended up to chlorine. As a result, C bond Cl becomes partial double bond. Hence removal of chlorine from chlorobenzene is very difficult. So here we are having double bond character takes place, and so chlorine cannot be removed easily. It makes chlorobenzene least reactive among alkyl, allyl and vinyl chlorides. So therefore we can say that benzyl chloride is most reactive and chlorobenzene is least reactive. So if we are seeing the serially, we can say that benzyl chloride is more reactive than alkyl chloride, which is more reactive than allyl chloride, which is more reactive than vinyl chloride, which is more reactive than chlorobenzene. That means chlorobenzene is least reactive and benzyl chloride is most reactive. The reactivity of aryl halide is minimum and reactivity of benzyl halide is maximum. So benzyl halide is most reactive and aryl halide chlorobenzene is least reactive. Thank you.